All right, 4.2 part 2. So we're continuing with our polynomial operations. We're going to focus on multiplying them, and we have some shortcuts for multiplying. All right, so these are shortcuts when multiplying out our binomials or whatever polynomials that we have. These are special product patterns. So we have sum and difference, which we've talked about before. We have the conjugates of two binomials. So if I had something like x plus 3 times x minus 3, the shortcut would be x squared minus 3 squared, which would be 9. So you could do the shortcut. You can always just multiply it out and FOIL it out. That would be like the long way. But this would be a shortcut way. If you have a binomial squared, so if you have a plus b, the shortcut would be a squared plus 2 times a times b plus b squared. Again, you can always write it twice and FOIL it out if you forget the shortcut. Same if it's a minus b, the first sign's just going to be minus. And then if you have a binomial cubed, so a plus b would be a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed. So again, if you forget the shortcut, write it out 3 times, FOIL them all together. The cube one, when it has minus in the middle, the signs alternate. So it goes minus, plus, minus. In example 5a says prove the polynomial identity for the cube of a binomial representing a sum. So we're proving what we just saw on the last page. So what we could do is just multiply this out. So the shortcut would be using this. The long way would be a plus b times a plus b times a plus b. How would I multiply 3 binomials? Perfect. So we want to start by multiplying 2 of them together, and then we'll multiply the third. How do I multiply 2 of them together? What do I do? FOIL. So a times a would be a squared. A times b would be ab. B times a would be ab. And then b times b would be b squared. So when I simplify this, do I have any like terms? Yeah. What is ab plus ab?
2ab.
2ab. Perfect. Now we can take this guy and multiply it to the third one. So make sure everything in the first set gets multiplied to everything in the second. So starting with a squared. A squared times a cubed. A squared times b, a squared b. And then moving on to the next one, 2ab times a, 2a squared b, perfect. 2ab times b, 2ab squared. And then b squared times a, ab squared. And b squared times b, b cubed. Let's combine our like terms. So we're going to start with a cubed. Then we have a squared b plus 2a squared b. What would that be?
3a squared b.
Awesome. 3a squared b. Then we have 2ab squared plus ab squared. What do we get when we add these together? 3ab squared plus b cubed. Did we get the same thing that our shortcut formula says? Yep. So we did 3, 4, 5, and 6 yesterday. We're going to do 7 and 8 using our shortcuts. So when we have a binomial squared, our shortcut for this one is a squared plus 2ab plus b squared. So where our first term is our a and our second term is our b. So we're applying the shortcut here. But remember, how else, if you forget your shortcut, how else could you multiply this out? Write it twice and FOIL it out. So when I use my shortcut in the a squared, I'm going to put 5a. So we have 5a squared plus 2 times 5a. What's our b? 2. So times 2 plus 2 squared. What's 5a squared? Awesome. Don't forget we have to square the 5 and square the a. So that would be 25a squared plus our middle term. We have 2 times 5a times 2. So let's multiply the coefficients together. What's 2 times 5?
10.
And 10 times 2? 20. So 20a plus, what's 2 squared? 4. So that would be our answer.
That's just like the faster way to do it.
It's technically the faster way. It would only really, it's only a lot faster when it's like cubed. It's kind of still the same amount of steps if you were to FOIL it out. Did anybody FOIL it out and get the same answer? Perfect. So foiling it out works too. Just don't forget, write it twice, FOIL it out. All right, for 8, we have xy minus 3 cubed. So here, we have 3 of them. It'll take a little bit longer to write it out 3 times and cube it, but we're going to use our shortcut. So our shortcut for cubed, when it is minus, is a cubed minus 3a squared b plus 3ab squared minus b cubed. So the signs alternate to help remember the signs. It goes minus, plus, minus. And then the a's descend. So it starts with a to the third power, a to the second power, a to the first power. The b's ascend, so they go up. It starts with no b, b to the first power, b to the second power, b to the third power. So it's kind of, I don't know, one way you can think about it. Both the terms in the middle get 3's. Again, if you don't remember, what can we do?
FOIL.
Write it out 3 times, FOIL them out. So here, our x and y, our x times y is our a, and 3 is our b. So let's plug everything in. We have xy cubed minus 3 times xy squared times, what's b? 3 plus 3 times a, which is xy, times b squared, which is 3 squared, minus b cubed, so 3 cubed.
So you don't use the negative? You just put 3?
You don't use the negative because you're using the signs from the formula. So your a is just xy and your b is just 3. So here, be careful because xy to the third power gets distributed to both the x and the y. So it would be x to the third power times y to the third power. Minus our coefficients, which would be 3 times 3, which is 9. And what would come next?
X squared, y squared.
X squared, y squared. Plus, what is 3 squared? 9. And 9 times another 3? 27. X, y. Minus, what's 3 to the third power?
9.
3 to the third power.
Oh, 27.
27. So this would be our answer. So when it's cubed, the shortcut is a lot less steps because you would have to write it 3 times, FOIL 2 of them together, then multiply the third one. But if you forget the shortcut, then just stick to multiplying. If you don't want to ever remember the shortcut, stick to multiplying. We're going to skip this page because, again, it just says prove, so we would just write it out and multiply. This is our formula that we use. We're going to skip B, and let's go to the next page. So next we're going to talk about Pascal's triangle. So Pascal's triangle is, again, like a shortcut that we can use to multiply binomials. So it's binomial expansion is what it's called. Pascal's triangle, these numbers on the side represent our coefficients. Oh, I'll zoom out so you guys can take a picture if you need to. Oops. There. So if you have something to the second power, to the third power, we saw that it might just be easier to multiply it out. But if you get something to the 5th power or the 6th power or the 7th power, you'd be multiplying all day. So Pascal's triangle is a nice little shortcut that we can use to help us with multiplying. So Pascal's triangle, the numbers here act as our coefficients. You don't have to really memorize this because you can always just write it on your own. It starts with a little triangle of ones, and then the number below is the sum of the 2 numbers above it. So like 1 plus 1 gave us 2. And each row starts with a 1. So if I were to create a 6th row, I have start with a 1. Then next I would add 1 plus 5, which would be 6. Then 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. And 5 plus 1, 6. And then we always end with a 1. So you start with a 1 and end with a 1 in each row. The first row of 1 is like row 0. The row number is always one of the numbers. It's always the second number in your row. So this would be row 2. Next row, the second number is a 3, so this would be row 3. So if we have a binomial to the 3rd power, we're looking at the coefficients from the 3rd row. Now these are just our coefficients that we're going to use. We have variables that go along with it. So if I had, it uses A and B here. If I have, let's look at the 3rd row. So A plus B to the 3rd power. We start with A to the 3rd power, then go A squared, then A to the 1st power, then lastly we have no A. B, just like before we said ascend, so it goes up. We start with no B, B to the 1st power, B to the 2nd power, B to the 3rd power. And we use the coefficients as 1, 3, 3, 1, like we have from row 3 of our triangle. All right. So when we are using Pascal's triangle to solve, so the power of A begins with, it says n, and decreases by 1 each term that we have and ends with 0. So whatever our exponent is, that's the power that our A starts with. The power of B starts with 0 and increases by 1 each term. So if I had, let's say, x plus y to the 6th power. The coefficients are going to be from the 6th row of my Pascal's triangle. So we wrote the 6th row on the last one. It was 1, 6. What came next? 15, 20, 15, 6, 1. Now, the x, so our first variable, we're going to start with x to the 6th power. Because our variable that we start with is the 6th power. And we're going to go down from there. Then I'm going to have x to the 5th power in my next term, x to the 4th power, x to the 3rd power, x squared x to the first power, and then x to the power of 0. But what is x to the power of 0? 1. So it technically goes away. It's just 1. With my y, the second variable, the second term that we have, we start with y to the power of 0. What is y to the power of 0? 1, so it's just going to go away too. Then y to the first power, y to the second power, y to the third power, y to the fourth, y to the fifth, and y to the sixth. Now when we write all of this together for our answer, we're just going to keep each column and multiply our terms together. So this would be 1 times x to the 6th power, which would be what? X to the 6th power. Then plus my next column, six x to the 5th power times y to the 1st power, which is just y. Then our next column would be plus 15 x to the 4th power y squared. Bless you. Then our next one would be plus what? 20x to the 3rd power y to the 3rd power. The next would be plus 15x squared y to the 4th power. Then plus 6xy to the 5th power. And then plus y to the 6th power. So this would be our answer. Yeah, and imagine multiplying it out 6 times. Lots of room for mistakes if you do it the long way. So let's start with A. So we have z plus 3 to the 4th power. So we're using the 4th row of Pascal's triangle. What are the coefficients from the 4th row? So it's going to start with 1, 4. What came next in the 4th row? 1, 4, 6, 4, 1. Right, now our first term is z. So we have z. What's the exponent on z going to be? Z to what power? Z to the 4th power, because our exponent here is 4. What's the next one going to be? Z to the 3rd power. It goes down from there. Z squared, z to the 1st power, and z to the power of 0. What is z to the power of 0? 1, so it goes away. Next, we're going to have 3. So 3, what's the exponent on 3 going to be? No, 3 to the power of 0. The second one goes backwards. So 3 to the power of 0 is 1, so that one goes away. Then we have 3 to the power of 1, 3 to the 2nd power, 3 to the 3rd power, and 3 to the 4th power. All right, so let's multiply our columns. What is 1 times z to the 4th power? Z to the 4th power. Next, I always like to multiply the numbers together first, and then we'll just put the variable on it. So what is 4 times 3? 12. So we have 12 z to the 3rd power. Then plus, what is 3 squared? 9. So we have 9 times 6 here. What's 9 times 6? 54, so 54z squared. What is 3 to the third power? And what's 27 times 4? 108. So 108z. And then lastly, we have 3 to the fourth power. What's 3 to the fourth power?
81.
81. So plus 81. So this would be our answer.
Yeah.
So if you guys, one way to create the triangle, I know I keep asking you what's next, but if I had the quiz and I had to write the triangle out, you start with a little triangle of ones. Every row starts and ends with a 1, and then it's the sum of the two numbers above it. So it'd be 1, 2, 1. The third row is going to start with a 1. What would come next? 3, and then 1. Fourth row is going to start with a 1.
6, 4, 1.
And the fifth row?
5, 10, 10, 5.
You guys are geniuses. Look how good. Well, the next question's asking for what? What exponent? 5. So we're using which row? The fifth one. So we have, I'm going to write it over here so we have a lot of space. 2t minus 1 to the fifth power. So the coefficients I'm going to use are 1, 5, 10, 10, 5, and 1. Now in my next row, I have 2t. 2t to what power? To the fifth power. And then it goes down. So 2t to the fourth, 2t to the third, 2t to the first, which would just be 2t, and then 2t to the power of 0, which is 1. So it goes away.
Wait, there's 2 10s?
Yes, there's 2 10s. All right, next we have 1. Our next term is 1. So 1 to the power of? 0. It goes backwards. Then 1 to the power of 1, 1 to the power of 2, 1 to the power of, 1 to the power of, and 1 to the power of 5. And 1 to the power of 0 is just 1, so that one goes away. Notice how in each column, what's 5 plus 0? 5. What's 4 plus 1? 5. 3 plus 2? 2 plus 3? 1 plus 4? 0 plus 5? So your exponents are always going to add to the exponent that your question has. So you can always check your work that way. All right, so let's multiply our columns. Okay, so we have to be careful here because 2t to the fifth power, we have to distribute to the 2 and the t. So what's 2 to the fifth power? 32. So 32t to the fifth power times 1 would just be 32t to the fifth power. Next.
Wait.
All right, 2 to the fourth power is what? 16. So 16t to the fourth power. What's 16 times 5? 80. So 80 t to the fourth power. Next, are you ready for the next one? We have 2 to the third power, which is what? What's 2 to the third power? 8. So 8t cubed. And 8 times 10? 80. So 80t to the third power. Next. What's 2 to the second power?
4.
So 4t squared. And 4 times 10? 40t squared. What's the next one going to be? 10t, perfect. And then the last one? 1. Now, with this question, because it has a minus in the middle, our signs just alternate. So it starts, the 32 is positive, then we go minus, plus, minus, plus, minus. So the signs just alternate. If it was a plus sign in the middle, every term gets a plus. But because this is a minus, we alternate signs.